So I'm just going to do a brief overview of reversal designs. And reversal designs are typically the most commonly used single case experimental design because it provides a clear representation of experimental control using a repeated introduction and withdrawal of an intervention, and it evaluates a direct replication of effect. So if we look here, this would be what would be considered A, or intervention of the AB design. So I'm going to draw an A here. Let's use a different color. A, okay. And with the baseline, for this it's the number of independent transitions that a student would make. And our intervention is going to be the use of an activity schedule to support independent transitioning through the classroom. And without any supports, the student makes between 2 and 4 transitions across the baseline phase. And we would predict that the student would not increase, but would have a similar amount of independent transitioning based on this baseline phase. And so, as you've seen in your textbook, you can also have what's called an AB design, where you have the baseline, and then you introduce the intervention, and we see a change in behavior right here. Okay, with the use of an activity schedule, the student is able to independently transition through the classroom between 8 and 10 times. And with this, we can say it's probable that the intervention was, that the behavior changed as a result of the introduction of the intervention. But we're not positive about that, so you would need to do more. So you can do what's called an ABA design, and this is where you reverse the behavior. Okay, so now we can be pretty sure that indeed when I remove or withdraw the intervention, behaviors go back closer to baseline. Certainly this was a little bit higher at first, but it's creeping down towards baseline and would most likely continue in that direction. And we see that only when the intervention is introduced does the behavior increase. Okay, but according to, in order to meet quality indicators for single case experimental design studies that could be used to determine evidence-based practices or be considered a study that meets with high standards, we would want to have a 4th phase where we reintroduce the intervention. And so there's a couple reasons why you introduce the intervention. If we stopped here, here, this wouldn't be an ethical thing to do. So you see the student can be more independent given this intervention. Why would we experiment with the student not having something that would make him or her more successful? So from an ethical standpoint, it is right to go back and introduce the intervention again. Okay, now I want to discuss whether or not this research here would meet research design standards as according to the Cradwell 2013 article that you've been reading. Okay, so let's go through and look at the indicators that one would need in order to meet standards. And the first thing is the research article systematically manipulated? And that means, does the researcher control the independent variable and when it is introduced? And so we would say yes, that's happening. So we have this baseline, and then the researcher has decided on session 5 we're going to introduce the intervention. The next thing in order to meet design standards would be that it's measured systematically over time by more than one assessor. And certainly we can't tell in this. We'd have to read the research study in order to determine whether or not this had more than one assessor measuring over time. But we do know that it's measured over time because these sessions reflect a period of time. Okay, starting with session 1 across to session 20, that was a period of time that was passed. And if that included having two different people looking at this data for a minimum of 20% of the time and agreeing at greater than 80% of the data that was collected, then we would consider that this meets that standard. The next thing is, are there 3 attempts to demonstrate an effect? And here's where we see the attempts to demonstrate an effect. So this is the first attempt from this point to this point. Okay, that's one demonstration of effect. Was there a change from the last point in the baseline to the first point in the intervention? And we would say yes. The second demonstration of effect is here between the intervention phase and the baseline phase. And the third demonstration of effect is here. Okay, so we do have 3 demonstrations of effect. So it does meet that standard. And then with an AB-AB design, we have certain standards with regard to the number of phases and the number of data points. So I'm going to bring in the Cradwell article for you to look here. And it says that it needs to meet standards with a minimum of 4 phases. So let's look. Does this meet a minimum of 4 phases? This is 1 phase. We've got 1 phase, 2 phases, 3 phases, 4 phases. So yes, it does meet with a minimum of 4 phases. And then the next thing is, are there at least 5 data points if we want to meet standards, or at least 3 data points if we want to meet standards with reservation? So if we look at the graph, there are 1, 2, 3, 4 data points in this phase. There are 1, 2, 3, 4, 5 data points in this phase. 1, 2, 3, 4 here, and 1, 2, 3, 4, 5, 6, 7 in the final phase. So if we look at the standards here from the Cradwell, it would not meet standards, but it would meet standards with reservation because it does have at least 3 data points per phase. Now, why would we only want to use 4 data points? Why wouldn't we do a minimum of 5 data points so that we could meet standards at the highest level? There are certain reasons why you might do that. For example, if in this instance, if we're looking at an activity schedule where the student isn't able to independently transition, and here the student independently transitions, and here we see the student under distress. Okay, that student is possibly crying or tantruming because he's not quite sure what to do. He's been successful in the past and now is showing some level of frustration. And if that's the case, then we don't necessarily want to continue with this phase for the full 5 data points. So it wouldn't be ethical or appropriate to upset a child. Let's say he's beginning to demonstrate some self-injurious behavior related with that frustration. It would make sense for us to stop the phase before the 5 data points. And we would justify that as we wrote in our article and described what happened, that we felt that it was important due to the safety of the child and the emotional health of the child to stop at that point. And in fact, we could have stopped here at 3. We see a clear trend. Even with those 3 points, we didn't really necessarily need the 4th point. So there are reasons as to why not to have 5 data points in a phase. And so one of the things you want to think about is what studies get used in evidence-based practices. And studies get used that meet standards, the highest level of standards, and those that meet standards with reservation. My professor, David Test, who's an expert in the area of transition, used to argue that they both get thrown into the same pot. So why should we make a child meet this highest level of 5 data points in a phase if we don't have to? And why does it matter when in fact both of them get treated equally when we look at an evidence-based practice, when we use the data from a study to meet an evidence-based practice or to assess whether an evidence-based practice exists? So you want to think about that. If it's not a problem for the student, then yes, have at least 5 data points. It will help, particularly as we get into talking later about using statistics to assess single case experimental design. The more data points that we have, the more strength a statistical analysis will have in assessing an effect size for a single case experimental design. And that's really why Cradwell and others have come to this determination that we need at least 5. But really, if you have 3, you can certainly demonstrate a trend, which is the main thing that you want to do in each phase, is this idea of prediction, that we have this trend and we can tell if the student continued in this fashion, they would continue on a slope line that is consistent. In the next video, I will go into greater detail about the logic behind reversal designs and why they are so strong in demonstrating experimental control or a functional relation between the independent variable and the dependent variable.